We looked at some fascinating pictures taken by the James Webb Space Telescope as it looks back to the beginning of time. This telescope has revealed something that challenges our understanding, piquing the interest of space scientists and researchers. This information reveals a possible Goliath event that could change the world as we know it. This finding is very important because it makes us think more about the real cause of our changed presence. The question comes up: could this information ever lead to the farthest reaches of what we think is the universe, to an event that is so unusual that we can't even begin to imagine it? Come with us as we talk about the latest news from the James Webb Space Telescope and look into how it might change the way we understand the world. The first part of our trip is an analysis of the obvious universe. The view we have into the huge area beyond the visible universe includes everything we could see, measure, and look at with our telescopes and space projects. The stars, universes, and heavenly things we can see make up a small but interesting part of the universe as a whole. It's a small part of a huge, unsolvable mystery that people try to study and understand. The general size and structure of the world are still a mystery because they don't change as we move through it. About 93 billion light-years separate the things that can be seen from each other in the universe. This amazing number comes from a number of factors, such as how far light can travel in 1 year and the universe's age, which is thought to be 13.8 billion years. Since the huge explosion, it is thought that the visible universe is getting 13.8 billion light-years farther away from Earth in each direction, making it at least 93 billion light-years across. That's what Hubble's rule shows. Space has been expanding since the Big Bang, making the visible universe bigger. Based on what we know now, the things that sent out light 13.8 billion years ago are about 46 billion light-years away right now. This theory says that the known universe grows more than 46 billion light-years from Earth in all directions. The unending chain of events that began with strong areas a billion years ago has not only caused the universe to grow, but it is also speeding up. It looks like confusing hours, like dark energy, are speeding things up and pushing the edges of the universe farther apart. As the universe grew, gravitational forces pulled particles closer together. This created amazing structures like stars, cosmic systems, and planets, which made me think of Earth. As proof that the universe can be measured, technical degrees of progress have made it possible for people to keep looking into a bigger part of the universe. Universe-specific cameras, like the Hubble Space Telescope and the James Webb Space Telescope, have made it possible to see stars and universes far away, making these amazing things easier for most people to understand. When you think about the cosmic field, it's interesting to see that the universe seems surprisingly empty, even among the planets that are close to Earth. Even if the nearest star was shrunk down to the size of a quarter, it would still meet with something 2 soccer fields away. This limitlessness grows only in our smooth wave framework, which is one of billions in the visible universe. It gives us a quick look at the hugeness of grandiose size. As we continue to look into it, the new information from the James Webb Space Telescope adds another layer of interest to what we know about the universe. It has made us wonder if there might be life in other universes and if big things could happen on an infinite scale. You might be interested in the reason we can't see the whole world. This cutoff is meant to make a few things clearer. Even though light is the fastest thing in the world, it takes a very long time to travel through space. This means that when we see things far away, we are really looking into the past. The farther away something is, the more its light has spread out to reach us. This creates a kind of pretentious time machine that lets us see worlds that are millions or billions of light years away. The expansion of the universe is another important factor at play. Imagine the outside layer of an inflatable that has been inflated to its full size. As the inflatable grows, the spots move apart. In the same way, grandiose structures float away as the room's area grows bigger. The light from faraway objects changes because of this growth, which is called redshift. The frequencies become longer as the objects move farther away. A couple of beautiful bodies finally reach a critical distance and show up at the grand horizon. From there, their light is too far away to reach us because the universe is always getting better. When you think about these two main ideas, how fast light travels and how fast the universe is expanding, it's not surprising that we haven't seen the whole thing yet. No matter how advanced our telescopes and technology are, we can't see all of the important parts of the world we need to learn more about. A changing measure of the universe's size is light years, which show how far light travels in a year. The Milky Way is about 100,000 light-years across. Proxima Centauri is the star closest to our Sun, but it is still 4.24 light-years away from us. We can see worlds billions or even millions of light-years away when we look into space. This lets us quickly learn about the early past of the universe. People from many different areas are interested in the mystery of the edge of the universe. There are still no clear-cut plans of action, but 3 huge theories have come up. The first one says that the world has no beginning or end and is infinitely big, expanding in all directions. The second one describes a small world with no clear edges, which is a lot like a big twisted or round space. At this point, going in an endless circle around any direction would eventually lead back to the beginning, like going around the Earth. The third idea, called the multiverse thought, says that our world might be just one of many, and each one has its own real rules and qualities. It's possible for these worlds to work independently or to be linked together, creating a huge and confusing multiverse. It's both logical and philosophically interesting to look into these theories. The idea that the world could go on forever changes how we think about space and how big it is. On the other hand, a limited universe without an edge makes us think about where the edges are and how things move. It suggests that there might be the possibility for models that stop and start within the surface of space. With its equal worlds, the multiverse theory suggests places that are very different from our own. It opens up possibilities that we don't fully understand yet. But it's important to remember that these ideas are still just guesses and are subject to more scrutiny. When you look into the edge of the universe, you see big changes that make it hard to fully support or explain current theories. This is because of the vastness of space and the limits of our observing tools and technological progress, which makes it hard to unlock the mysteries surrounding the universe's limits. Any way you look at it, the James Webb Space Telescope stands out as a sign of trust because it promises to help us understand the strange early stages of our world. It is clear that the James Webb Space Telescope is a game-changing tool that will make it possible to study the universe with unprecedented accuracy. This interesting instrument might be able to reveal the dark history of our world, giving us experiences that are far beyond what we can understand now. As a unique wonder, the JWST has recently revealed a lot, especially when it comes to looking at the edge of the world. One of the amazing discoveries is that 6 huge worlds might be coming back between 500 million and 700 million years after the Big Bang. This idea was published in the journal Nature. This review questions many common ideas about how universes began and how they changed over time in the early universe. Surprisingly, these old frames show widths that are much bigger than expected for their age. This tests hypotheses and changes the record of endless improvement in the rejection of initial assumptions. Stargazers were shocked to find these huge, grandiose substances after seeing such small, young cosmic systems. It's amazing how much these old cosmic systems have changed, like how our third Milky Way system is only 1 billion years old. The stars inside these huge monsters have an unimaginable total mass. Some of these huge structures may have a mass up to 100 billion times that of the Sun. The JWST's unmatched ability to learn about the secrets of the world comes from its use of infrared light, which the human eye can't see. This limit tells the telescope to look for tiny signals from old stars and systems, which shows galaxies that are billions of years old. The JWST is like a time machine because it sends our view back through the ages and tells us important things about the world about 13.5 billion years ago. The recent discovery of huge frames called universe breakers has changed how we think about progress that has no limits. These shocking discoveries question recently held beliefs, looking into the common belief that universes began small and grew steadily over time. With its high-resolution photos and spectroscopic tools, the James Webb Space Telescope has been a key player in revealing the mysteries of these very large universes, going above and beyond all expectations. The fact that very large black holes might be hiding beneath these structures adds another layer of wonder to the surface of the galaxy. Even if you only look at a quarter of the data, the known mass of stars in the universe may now depend on a shocking many times more than it did in the past. This new information makes us rethink how we could figure out the huge amount of mass and plan. Each new information adds to our huge map and gives us a clearer picture of the The universe is planned for meetings and growth. These huge, infinite systems have effects that go beyond their size, testing important ideas and making us rethink what it means to make infinite progress. We now have a much better understanding of the world thanks in large part to the James Webb Space Telescope. The JWST has made some amazing discoveries, like showing that the universes are the most stable and far away they have ever been. These frameworks take us back to a time when the universe was only a small part of its present age, about 400 million years after the tremendous event known as the Big Bang. The fact that the light from these worlds left on its journey over 13.4 billion years ago and finally arrived at our location makes things even more interesting. From the JWST's point of view, the first pictures it took were similar to the first pictures taken by the Hubble Space Telescope. These pictures showed different possible systems through modern spectroscopic analyses. Experts in space could have agreed with 4 of these divine quirks after looking closely at their physical components. Taking a close look at their faraway paths from us and figuring out the space between systems includes the idea of redshift, which says that things in space look like they are slowing down from our point of view because the universe is getting bigger. The Doppler effect is the name for the strange way their light waves relax and move toward longer frequencies. While different channels and pictures can give estimates of redshift, spectroscopy is the most accurate way to get accurate estimates, focused on 4 universes with redshift changes greater than 10. The JWST announcement makes a big deal out of how far away they are from us. This is in light of the fact that the Hubble Space Telescope had recently seen what looked like endless frameworks with red developments of 10.38 and 11.58. On the other hand, the JWST had seen 2 much farther away universes with red developments of 13.10 and 12.63. A redshift of 13.2 means that the event happened about 13.5 billion years ago, which is an interesting look into the past of the universe. The James Webb Space Telescope's Advanced Deep Extragalactic Study, or JADES, is proof of the telescope's powerful places. It was planned in 2015 by a group of instrument groups. 80 astronomers and researchers from 10 different countries make up JADES, which means around the world. They want to take a huge look back at the early stages of the world and reveal secrets that have been kept secret for a long time. By looking at the world through the lens of the James Webb Space Telescope, we can make discoveries that have effects that go far beyond simple understanding. The information this great tool gives us not only gives us small pieces of information about the beginnings of huge progress, but it also makes us think deeply about what truth is. The fact that these huge universes were around so close to the Big Bang goes against the widely held view that universes should grow slowly over billions of years. Instead, the data shows that conditions in the early universe might have allowed for quick development of the big picture, rather than being set in stone by interesting physical cycles that we are only now starting to understand. The JWST's ability to see in infrared frequencies is very important because some celestial oddities give off light that has been redshifted by the expansion of the universe, so optical cameras like Hubble can't see them. By separating this infrared radiation, the JWST finds protests that are usually hidden from our view, such as people who are star-forming in the area and worlds that are just starting out. This limit opens up a whole new area of astronomy and encourages scientists to learn a lot about the most important events in the history of the universe, such as how the main stars formed and how complex structures formed. Aside from what the JWST found, our knowledge of dark matter is being questioned. Dark matter is known to make up a big part of the universe's mass, but it is dangerous and hard to see. The existence of huge, infinite frames that don't skip a beat in self-important history makes people wonder how dark matter helped them get better. It suggests that dark matter may have played a more unique role in shaping the early universe than was previously thought. It may have changed the gravity forces that led to the formation of the infinite framework. Even though the JWST discoveries have changed how we can figure out how the universe works, they also give us exciting clues about the conditions for life beyond Earth.